Hello, everyone, and welcome to the penultimate 2018 Small Farms Winter Webinar Series, hosted by the University of Illinois Extension's Local Food Systems and Small Farm team. This is Zach Grant back again on moderating duties, and we really appreciate you joining us for these webinars, and we will do our best to begin and end within the space of our lunch hour. So this is a tight time frame for our educators to deliver their in-depth, actionable information. So if you could limit your questions to the text box during the presentation, that would be very useful. And if applicable, Nathan will try to answer that question during the presentation. If not, we will collect those questions and we will answer them at the end. This presentation is being recorded, and I will email a link to the archive presentation as soon as possible after this concludes. There will also be a link for a very, very short online evaluation of this presentation, and as always, we very much appreciate your feedback as it helps us shape future webinars. This week's presentation is from Nathan Johanning. Nathan is one of my fellow educators on the Local Food Systems and Small Farms team, working in Southern Illinois in the Franklin, Jackson, Perry, Randolph, and Williamson County unit. Nathan has a bachelor's and master's degree from Southern Illinois University at Carbondale in the area of plant and soil science with an emphasis on weed science. He served as both a teaching and research assistant in SIU's plant and soil science department before joining the University of Illinois Extension in 2013. Nathan is very involved personally and at the local level in both agronomic and specialty crop systems, with specializations in no-till systems, cover crops, high tunnels, and fruits and vegetables, with a particular interest in pumpkins, where he is often our go-to representative for this crop on the Local Foods and Small Farms team statewide. With that, I'll go ahead and let him take it away, and he's going to describe some DIY approaches to sprayer modification today. So go ahead, Nathan. Thank you.
All right, thanks a lot, Zach. So I would like to thank all of you guys for joining us for this presentation. So I'd kind of entitled this Tips for Modifying and Building Sprayers for Specialty Crops. So I want to start off by saying this is a really deep and kind of detailed topic. I'm sure there will be questions or nuances regarding an individual piece of equipment that I may or may not completely address, but hopefully in this process you'll have some good basic information to at least help guide your further questions. So with that, I will jump right in. So with this, I want to start by talking about sprayer uses on the farm, just ever so briefly. So how are we using them? Of course, most is for pest management, our common pest management products, also potentially foliar nutrients as well. And I do want to emphasize in this and remind people that whenever I'm looking at this could be synthetic products or it could be naturally derived OMRI-approved products. Both in any case need to have adequate and appropriate spray coverage, and an effective sprayer is the same tool no matter what products you're using. And also the need for effective calibration and making sure that you are putting on the right rate, no matter what product. That is very important. So I do want this to link across to all. Sometimes we maybe think sprayers, we think of the conventional synthetic pesticides first, but all of these need good sprayers and tools to be accurately and safely used. So what we're going to focus mainly on is boom sprayers. There are all kinds of air-assisted, air blast, and etc. type sprayers, and I will hint on to maybe some topics on that, but for the most part, what I'm going to focus on for the sake of this is boom type sprayers, and you'll kind of see and understand any more of that as we get into it. There's a few resources here that I'm going to refer to a lot, and you'll see some pictures and other things cited from. The first is this equipment calibration for low pressure sprayers. This is actually a University of Illinois publication. It actually is from 1981, so it is maybe a little bit dated by some references, and you can find the PDF of it. However, it doesn't have a few of the newer maybe pump styles, but for some of the basics, It gives some extremely good, straightforward images on how to plumbings and different features, screens, and other things that you need to put and where to put them. So it is certainly still a very good, valuable, applicable resource, because to be honest, a lot of the basic technologies that we're using have not changed. There's technology to maybe help us control the sprayer booms and things, but the concept of a pump, a tank, and some valves and things in between still remains almost identical, even on some of our huge field sprayers. Also, one thing that I found useful was this, especially regarding looking at pumps, which is where we'll start first, is this selecting the right pump. This is actually from Hypro. It is a pump company. And throughout this, I have references to various companies and some of their publications. I will say that I am by no means endorsing any of these companies. I will point out a few that are more common, but this is in no means is one better than another, and it's just simply things that have some resources out there and trying to give you some examples so you know where to go to and maybe some starting places to lead your endeavors as you're looking at some investing in a sprayer or modifying one. To start off with, before we get into that, pesticide use and safety is important. So the information here, I'm talking about the mechanics of spraying and some of the actual components of sprayers. I'm not going to get into any detail of calibration and protective wear and things like that, which is all very important, but for the sake of only having an hour, that's not what we're focusing on. Referred to, especially in Illinois, the pesticide safety and education team, which does pesticide programming, and their web link is listed there. And you can take trainings and testings to get to be a certified applicator, and that would allow you officially restricted use pesticides at your disposal if you wish to purchase those. My comment that I do like to share is even if you do not intend on using restricted use products, the training for the safe use, laws, mixing, calibration, and all of that is extremely valuable and is applicable to all pesticides, whether synthetic or naturally derived. So I would refer to that training and their resources more for sprayer calibration details and mixing details and all of those things. So, starting off, choosing a pump. I've started here because the pump is truly the heart of your sprayer. So you need to have a good pump that meets the needs of your specific goals. So we're going to spend the next few slides just kind of briefly outlining some kind of differences, maybe pros or cons that you might say about different types of pumps and which ones would be to help you guide on which ones you might want to use. The first thing to note that you might see in the references is two different types of pumps. You have positive versus non-positive displacement pumps. So, and there's a few bottom line differences that we'll get to on this. So a positive displacement pump is that the flow is directly proportional to the pump speed. And what this means is that every turn of the pump moves a given volume of water, and that water has to go somewhere. So you can't, if you turn off a valve, something else has to give somewhere in that system if that pump is running, or you will do damage to the pump or worse. So in this case, these must have a pressure relief valve, which we'll talk about in the plumbing section, but that needs to be between the nozzle shutoff and the pump. So where the pressure is coming in and you turn on and off your nozzles, you need a way for that pressure to relieve and go back into and recirculate into the tank. Examples of these would be a roller pump, diaphragm pumps, and then also piston pumps. So, and we'll talk about each of those, but those would be in the positive displacement category. The non-positive would be where you have flow that's created through an impeller through centrifugal force. So in this case, because there is not every turn of the pump doesn't necessarily move a specific volume, it's just that centrifugal force creates, by spinning, creates that pressure. You can shut the valve on, say, to your nozzles, and that impeller will just continue to spin free without damaging the pump. In this case, we use what is called a throttling valve, which basically controls the amount of flow going out into the boom and nozzles. An example of this would be a centrifugal pump. So, how do you know which one to choose? For one thing, look at your power source. A lot of cases, I'm guessing your power source is going to be maybe a tractor, a PTO from a tractor. Some cases we would use an independent small, maybe 2 or 4 stroke gasoline engine that's just dedicated to the pump. In some cases it'd be electric, and by that I mean 12 volt, say a battery operated from a tractor, ATV, lawnmower battery, whatever it might be. And make sure for some of these that your pump and source spin in the correct direction. The big difference is the difference between a tractor PTO and a lot of our say our independent 2 or 4 stroke engines. Make sure they make sometimes the spin of those would be opposite of maybe what some pumps would be. It's very easy. Usually they will list on your pump, the direction, and so make sure that those match up. Otherwise, you'll be less than enthused with the initial result. So just basic housekeeping things to save yourself maybe a headache in that purchase. Know your approximate output size that you need to pump. You're going to be able to calculate this looking at the total volume per acre that you're looking to achieve, and from there look at your nozzle size and the number of nozzles. And some of this will make a lot more sense as we get through to those components. You'll see the different nozzle sizes and things, but a lot of it starts at that initial spray volume that you're looking to achieve, and hopefully by the end of the presentation we'll have kind of given some more guidance on that. But you want to know where you need to go, so that way you have a pump big enough to deliver what you need it to and the pressures that you're looking for. This is a little table here. It actually does come from that Hypro publication, and I just liked it because it did a fairly straight breakdown of your power source and the different types of pumps and where they fit and didn't fit. So why are pumps different? This is a really good illustration just from the fact that it does give a good breakdown of, in this case, the centrifugal pump, which is at non-positive displacement, compared to a roller pump in their output. So basically you can see at a different pressures that are out there how much volume, as you can see on the vertical axis, you can achieve. So what this shows is that our roller pumps can achieve really higher pressures fairly easily. However, they do not have a huge amount of volume. So the bigger your sprayer is, you may need to move to something like a centrifugal pump, which in many cases where if you're needing a higher volume, it is good because you can move a large volume of water fairly quickly. However, the pressure ranges on it tend to be maybe not as high as what maybe a given roller pump would be. So that's just one illustration of, if you're looking for pressure, a smaller pump or a smaller setup that you need higher pressure for, or you have a little bit larger pump and sprayer setup needs. In that case, maybe a centrifugal pump would deliver the volume you need and still give you some the adequate pressure. So we're going to jump into just a slide on each of these different types of pumps. So roller pumps. These are of any of them probably fairly economical, compact, easy to use. They're repairable. The rollers inside. There's rebuild kits for seals and rollers. Their output is anywhere from roughly between 5 to 30 gallons per minute. And you can achieve some fairly high pressures if needed with them. They are a little bit more prone to wear from abrasive materials in the spray solution. So rollers and things can wear over time. Not that it can't be used, but if you're using maybe dry products that are more abrasive or flowable products, you may have to maybe rebuild that sprayer every once in a while compared to some others that are a little more durable to wear. By and large, for a lot of our tractor sprayers, roller pumps are probably one of the go-to pump types that we would utilize. They're fairly effective. They do self-prime, which means that a good roller pump will suck uphill a little bit to pull that solution in. Some pumps do not do that, so you have to make sure the tank is mounted above the pump, so that way you don't have issues getting the solution to start flowing through the pump. Centrifugal pumps, I would say, are probably one of the next popular ones for tractor sprayers. They are very durable, have a simple construction. Again, these are the non-positive displacement, so you do use a little bit different system for modifying pressure. They do have a lot higher potential for volume. So if you're needing a moderate pressure for a boom sprayer, but needing the volume and not needing high pressure, say over 100 psi, although those can achieve that for a modest size sprayer that needs modest pressure but high volume, centrifugal pump can be a really good choice. It also can handle those abrasive materials better because you don't have some of that wearing action in this type of pump like you would, say, on a roller pump. Diaphragm pumps. So these pumps, they have basically a synthetic diaphragm that has cylinders underneath it that pump to basically create that pressure and pull. They do have a pretty wide range of flow and pressure capacities. They are good for corrosive and abrasive materials, whereas a lot of our others do have some form of metal component that can be prone to corrosion. More so, the fluid part is usually always encapsulated inside that synthetic, usually like a rubber type diaphragm. So if you happen to be using, say, liquid fertilizers or some solution that tends to be more corrosive, these will handle that much better. Also, diaphragm pumps are one of the more common pumps that you would see for your small ATV sprayers and other 12-volt pumps that you have available. Often these are, for pressure-wise, are self-regulated on these ATV models with an on and off kind of pressure switch because they're electronically controlled. So you will, in this case, you would actually kind of treat it a little bit more like a non-positive displacement, in that you would use a throttling valve if you're trying to adjust the pressure beyond what the just that internal regulation of that pressure switch within that electric pump. Otherwise, if you have a PTO or other engine-driven diaphragm pump that's continually spinning, it is, in this case, you would need to have a pressure relief valve so as not for it to build up pressure when you don't have the sprayer boom on. Piston pumps are also out there. They function very similarly to how a gasoline engine pump functions, with pistons and valves to move the liquid. They are fairly low output, but they do obtain some really high pressures. I will say that of these, the piston pumps are not extremely common. They might be on maybe some smaller sprayers where you maybe just have a wand and you are trying to achieve higher pressures, maybe for spraying fruit trees or something. You might see these. However, more commonly, I think anymore, we probably see more small diaphragm pumps, especially if they're electric, utilized than piston pumps. Oftentimes, I think many of our pressure washers and things utilize piston pumps to get that high pressure where you're having a fairly low volume. But for our spraying, say our pesticides and other things for crop protection, often we don't see these as commonly as what we would maybe the other pump styles. All right, so I mentioned pressure control. So remember with the positive displacement pumps, you do need a pressure relief valve. This is kind of diagram of basically what it is. Basically, there is a spring and a piston in there that as you tighten it down at given pressures, it will bypass and allow fluid to that would come in to then go into a bypass line that would then recirculate back into the tank so as not to put back pressure on that constantly spinning pump and cause damage. The throttling valves are used again for the non-positive displacement, mainly our centrifugal pumps, and basically that just dials down the volume that is flowing, and by that volume control, that's what's controlling the amount of pressure that you're achieving. Agitation. So in-tank agitation for our materials is really important, especially if you have dry or flowable materials that settle out easily or need extra help to mix. Even if you do your best to keep keep a strong stream of fluid when you're adding those chemicals and components in there, there's still a tendency, especially with no agitation, and if that tank sits still for any amount of time, things will settle out. And it can be without some form of agitation in the tank. It'll be really hard to get those particles back in suspension, which number one, it's not good for screens and nozzles because those particles can plug up inlets and other things like that. But also that you need to have a consistent, even spray solution throughout that tank, because you might get the active ingredients you're needing may be settled out in that material on the bottom, and if they're not thoroughly mixed in, you might be spraying a really weak solution at first and then a really too concentrated solution at the end. So I always encourage some means of having some agitation in a tank, and we'll talk maybe more on some ways in the future slides as how to achieve some of that. Also, strainers is a really important component. In some cases, we want to have some inline strainers between the tank and the pump, or maybe in some cases after the pump. Some of that depends on the system, which we'll address here in the next few slides. But for the most part, we do want to make sure that we have screens in our nozzles. So these are basically small screens that fit up inside the nozzle body that actually hold some of our different sprayer nozzles. There's two that I have pictured here in the red picture below, and that would be the ball check, which is on the one on the left, and then a non-ball check screen. And I'll talk a little bit about when we need to use each of those, but note that also all of these screens, nozzle screens, are color-coded by size. So the red is a 50 mesh, which is shown here. Green is 100 mesh, and then there's others above and below that. The mesh, what that means is that it's holes per square inch. So basically, the larger the number, the smaller the holes. So the larger number of holes that there are in a given square inch, that means that is basically a finer screen. A lot of that what screen you choose is going to be based off of the specific nozzle. Generally speaking, if you have what we call an O2 nozzle, which I'll talk about later in the nozzle section, or larger, for the most part, a 50 mesh screen is probably going to be your go-to screen. However, if you get smaller than that, or in some other certain circumstances, depending on the design of the nozzle, you may need to go maybe to a 100 mesh screen. And there might be some large nozzle orifices that you may actually be able to step up to maybe something even more coarse. But if you're looking at nozzle selection, when it comes to that point, all the manufacturers are usually very good about having reference tables, and they will very clearly state, the mesh size of the screen that should be accommodated for that nozzle. And I would follow that, because that's, through their research and engineering, that's what they've come up with, and that would be a great start. Boom control valve. So whenever you get all these components together, you need a way to control the flow out to the nozzles and sometimes different sections of the boom. So you can, in some cases, on larger sprayers, and by large, even something that has a 10 or 20 foot wide boom, you can get devices that will allow you to turn on or off all or parts of the boom, which are some of the ones that are shown here. So in this case, all of these are set up for basically 3-section booms. A lot of times you have a left, center, and a right. And I'll show some other pictures. These are manual versions, some of which you have individual levers that you throw for each section. Also, this in the image on the upper right, you have a kind of a combination valve that you can rotate the lever, and it will, depending on where you have it rotated, when you flip it up, it will turn on 1, 2, or 3, or all sections of a given boom. And then the electronic version of that, an example of that is listed below, and this is a situation that would be coupled with some electronic valves and also a electronic pressure regulator. So in this case, for a more advanced system, you can actually control your pressure through either a throttling or pressure relief valve electronically. And then you have subsections to turn on or off left, center, and right booms, and there's a master, so you can just easily turn on or off the whole works. You'll see in some other images later, you can also make your own. You can use a series of valves and fittings and just plumb your own. Things need to come in, you need a spot for a gauge, you need agitation, you need a line going out, and you need a valve on that line going out. And so you can certainly, with some of this basic information, you can create that. I will say, even from experiences, as you're looking into this, don't always think that, oh, well, I don't want to spend maybe even $70 or $100 on one of these control valves when I can just go and just buy some valves and go from there. My experience is that these valves and little pieces can add up, and I've tried to do this, and sometimes I ended up spending more money than I would have if I had just gone and bought the control valve that was pre-made already. So do a little budget work. There are some situations where it does make sense to just to plumb something yourself, but keep that little note of experience in mind. So, positive displacement pumps and systems. How would you plumb it? So this is a slide this and the next one that gives some really good illustrations of all those components. I wanted to outline those before I showed you this, so that way you kind of knew what these individual components look like prior to that. So let's just start with the tank, because that's usually where we need to start with on our system. So as you have that tank, you can see as you go down from there, you will have, in this case, this could be a roller pump or any other positive displacement pump. It would be good to have a strainer or inline strainer in that system that will catch pieces, especially for some of the positive displacement pumps. They can be a little finicky about damage can be caused if a particle or piece would get into the pump. So you want to have a strainer in there, so that way that would catch some level of debris. That does not necessarily need to be as tight of a strainer and screen as you would put on your nozzles, but it's mainly just to remove some of those larger particles. From there, you can also go ahead and put an additional strainer on the other side of the pump, and this will help to again catch some smaller pieces. I would certainly, as you're doing this, I would I would put your largest, the largest screen size or the smaller mesh size on the inside, and then work your way to a smaller mesh size as you get closer to the boom. And certainly if your nozzles have 50 mesh screens in them, I don't see any real reason to put a finer or smaller screen in anywhere else in your system, because in some ways that could potentially slow down the flow of liquids through your system. As you go up, you do need to have a way to agitate the tank. So here they show, this is what I mean by tank agitation. In this case, they have this example has a direct line through that has holes, which is allowing the solution to come out and especially hit that bottom of the tank, and then try to help recirculate and pull some of that up to keep things from settling out. You want some kind of a control valve there. Could just be a simple gate or ball valve to manage how much goes into that tank as to recirculate for agitation. From there, you will go up and you will have a pressure relief valve, and that will bypass and go back directly into the tank with no restrictions on flow to recirculate anything whenever the boom is shut off. And from there, you will go to your control valve. So that allows you, in this case, it's showing again for like a 3-section boom. Those can be turned on and off, and then controls the amount of flow going out to the boom. Also note that at that point, and that in the sprayer is commonly where we would want to, near our control valve is where we'd put a pressure gauge to help to tell us where we're at on pressure. You will also see sometimes you would want to at least check the pressure at your nozzles. They make pressure gauges that you can snap on to nozzle bodies, or you could plumb one in line on your boom, just to make sure you're not getting some pressure drop between here and there. That's not something maybe you would look at on more of a moment-to-moment basis, but it's something that would be good to check at some point in the building and use of your system to make sure that you don't have any inefficiencies, so to speak. All right, so a non-positive displacement system. So this is a centrifugal pump. So this is a lot of similar concepts. In this case, they've showed some a little bit different options in this. I won't go in maybe as much detail, but I'll hit on some of the highlights. So in this, you're not necessarily going to need to have a strainer between the tank and the pump. Centrifugal pumps have the ability to handle, due to their nature, handle small pieces and particles, so that's not nearly as potentially problematic. However, it would still be good to put a strainer on the other side, so that way you are removing any impurities that might then be heading into the rest of your system, control valves and other things, especially larger pieces. As you go on up, you would again need agitation. This has a different form of agitation that has more of kind of a jet agitation, which can, in this case, they're showing them being plumbed in from the bottom of the tank. For smaller tanks, you can also put a threaded bung or drill a hole in the side of your tank and just put one of these jets in the side of your tank, and it would would be able to agitate across the bottom in that similar location. Larger tanks, it would be a good idea to have things going out in multiple directions, so you make sure that you don't have too many maybe dead spots or voids in flow where material could settle out. From there, the main differences come here, and I want to kind of emphasize this a little bit, is that your throttling valve. So you don't have a pressure relief valve. Note that there is no bypass that goes back up into the tank. That throttling valve just basically literally throttles down or dampens down the amount of flow that can get through, and therefore that will control the actual pressure that is out in your boom. Here they can show one of those rotary boom controls that again has multiple it's manual in nature, but has multiple positions to control all or separate sections of the boom. All right, so that's a little bit about. We spent a little more time there, but that's a very important kind of starting point as to where to go when you're trying to actually figure out, how to put all these pieces together. So a little bit more on some notes on components. Tanks. You can have polyethylene or stainless steel is probably the best materials. I would say by and far, most all of you are going to have some form of a polyethylene tank. The stainless steel, it's nice if you happen to have maybe you buy an old sprayer and it happens to have it, but obviously the stainless steel is more expensive and certainly is not necessary. I think the polyethylenes are common, many shapes and sizes available and work great. Um, Avoid using galvanized tanks, which were sometimes used if you had maybe bought an older sprayer due to corrosion, corrosiveness of even just some of our common products and pesticides, not to mention just having water or liquid in them. You can over time, if they're older, they get some rust in them. You get rust flakes, and rust flakes never do good things for sprayers, especially sprayer nozzles. Sometimes you may have some older sprayers that have fiberglass tanks. If the tank's all right, that would be fine. I would not go out of my way for this, and do watch because some of these fiberglass can get brittle with age. And so that would not be something I would seek. Again, if you happen to have it, it doesn't, I wouldn't be as worried about the corrosive part of fiberglass, but as I would the galvanized. But just some notes. Polyethylene is probably going to be your go-to. Used tanks. You might purchase a sprayer from a farm auction or just for sale by a local grower. Older sprayers can be great resources. So you can use a used tank. I would look and see how much residue is in it. There will be stains and things in tanks that you may never be able to get out of, and a lot of times they will be there and they're not going to cause problems for you per se. But if you are doing it, make sure it's cleaned well for physical particles, and then for the residues, make sure to use a commercial tank cleaner. You can find these at farm stores and other places. Often these are ammonia based. They are a lot more concentrated, just household ammonia. Follow the directions on them, especially at first, and fill the tank, let it soak, and do a really diligent job of cleaning it. And if it's in decent shape, certainly you can utilize that. The shape of the tank. For smaller acreages, consider, for one thing, a tank size that fits roughly with the size of batch you want to make. You don't want a 300-gallon tank whenever you only are mixing up 50 gallons at a time and have no need to ever mix 300 gallons, because that 50 gallons will almost get lost in that big of a tank, and if you turn a corner, it goes to one side or the other, and it can be hard to keep constant flow. I showed a picture. This is, and I'm sorry I didn't have a better picture for it. It's what I had on hand. This is a research sprayer we actually have at one of our research facility, and what I wanted to note on it is it actually has a kind of a tapered bottom tank, which is excellent. From the perspective, if you're mixing small quantities, it's very easy to get that tank to clean almost every bit, maybe but a cup or two of liquid out of the bottom. Some tanks with a very flat bottom on them, it can be very easily, especially if you either get to a slope or even just have a small batch, it can be very hard to get all of the material out of that. So, and you want a tank that drains out well and drains easily, so that way you can easily clean it, and especially if you're switching between different products, and easily get that tank cleaned out. So that's another thought and consideration if you're building them. Sprayer booms. There are tons of different configurations for booms, for sprayers, and a lot of this should just coordinate with your ending desires and goals. So, big field sprayers have booms as much as even 90 or over 100 feet wide. Well, most of the times for some of our crops, you're not probably talking about that, but A boom can be as simple as one nozzle that's spraying, 15 or 20 inches wide. You're in complete control of how many nozzles and where you configure them. It could be something very specific to your needs, and you can do that, and you can run a line and a nozzle and clamp it on a boom, and you're good to go. If the boom is a very wide, you should have some form of breakaway system. Oftentimes, this has some system of springs or something that would allow to hold the boom mostly in place, but it would allow it, if you touch on something, that it would swing forward or back and give it at least some level of flexibility. Although you might think that you're a really good driver if you have even a 10-foot wide boom, sometimes when you're trying to do this, that, and the other, it is easy to catch a fence post or a tree branch or something. And with even a little bit of forgiveness, you can that boom will bounce back and be completely unaffected. However, without that, you can have maybe some booms that you have to straighten at the end. So sprayer boom setup. I'm going to refer to this really good University of Nebraska publication, which is linked here. And we'll share that link with you also in the chat box. This is a great description of some different boom types and some good pros and cons and things, more than what I have time to go into in the time of this presentation. But refer to that, and that gives some more nuances on some more details on how to configure your boom as far as physically maybe laying it out. Boom design. So with that, there's all kinds of configurations. You can have a straight boom with equal sections on each side. That's very common for just doing broadcast applications of herbicides, maybe even some fungicide and other applications. You can do an offset boom that's all on one side. I find this very helpful for if you have a block of a crop with maybe drive rows down it, you can have that boom going out to one side and then just spray over that alley, and then not having something maybe in your wheel tracks. You can also accomplish this with a larger boom that's mentioned in that first, just a straight boom with equal sides and probably maybe turning off the center. But that's a really good another way that if you're building it, you may not need to fill out have both sides. One side offset beside your implement or tractor you're pulling it with might give you a lot of effectiveness. You also might do a smaller offset boom that could go for spraying maybe weed control products under perennial tree, fruit, and bramble crops, grapes and things. You might make a small couple nozzle boom that is mounted, maybe in this case even on the front of a tractor, where you can watch it and you can drive along, say, to capture weeds under the understory of some of these crops very easily with utilizing a tractor or maybe even ATV or something, rather than having to do that by hand. You could do a offset vertical boom, so saying a boom that's offset to one side but having it go vertical rather than horizontal. This could be good maybe for spraying trellised or staked tomatoes or peppers or some other smaller fruit crops. So basically just taking that per boom and standing it up. It may only, in some cases, maybe it's only 2 or 3 nozzles, but you could drive down a row and then apply a product to that vertical surface, because in this case, maybe having a nozzle coming from overhead doesn't really give you the coverage that you need. You can also do a higher boom with drop nozzles, and basically this means where the nozzle comes out, you put an extension on and the actual spray solution comes out lower. This is great when we're trying to spray sweet corn during tassel time for corn earworms, and we really want to focus our spray on the silks. We can with a sprayer with a taller boom, we can drop in and then apply a product then in that zone right where we need it. And from there, these are just some examples. I mean, the sky is kind of the limit based off of what you need in your specific situation, the implement you're going to use, and all of these factors as to what makes sense. So there are 2 different types of booms that we would utilize. So you can use a a dry boom, which in this case the solution flows via hoses and nozzle bodies, and those are attached to a separate rigid frame. This is the most common and most simple to assemble, and also manufacturers most all make nozzle body clamps that will fit off on various tube shapes and sizes. So it's easy to mount those nozzles on, say, a rectangular or round pipe or box tubing. Wet boom is another option. This is where the solution actually flows through the pipe that is also the structure of the boom. So you have a round pipe, and basically you have a nozzle body that clamps around that pipe, and you have a hole drilled in it to access that. This does allow for higher flow rates and also a better ability to clean and flush the boom. You have less connections, barbed connections between hoses and nozzle bodies, so it's a lot cleaner inside as far as trying to flush out. Now on the side that's a little bit of a struggle when you're making these on small scales is that really the best thing to use for these is going to be a stainless steel for that actual wet boom because of the especially the corrosive nature of things. In older sprayers they did use galvanized tubing for that. I don't necessarily recommend that. And in some cases there could be some plastic products, but that are also useful. Do note in some cases, one might say, well, what about PVC piping? Be conscious of that and some of your potential pressures you might get to, and also the bigger thing is making sure that any adhesives you would be using would not be broken down potentially by some chemicals you might be utilizing. So because you certainly would not want one of those glued fittings to come apart. So that's one aside. I wanted to mention this as some differences because it might be something you see. And for more details, especially on these differences in the construction techniques, refer to this. Again, this is that same Nebraska publication because it has some really good details even onto price comparisons between the two systems. All right, nozzle spacing. So looking at your boom, how are you going to space your nozzles? The standard would be 20 inches between nozzles. That is kind of an industry standard. You can adjust to really anything you want. Typical range would be anywhere from 15 to 40. I would say unless that you have a specific need for something otherwise, 20 is perfectly adequate, and I think that would be a go-to starting point. So why you would go different would be to space things based off of sprays between crop rows. Say, for example, use a 15-inch spacing and use every other nozzle to be able to direct a spray between 30-inch rows. In some cases, our sprayers may be used even to deliver maybe fertilizer even, say, like a liquid nitrogen between corn rows. In that case, if you have 20-inch spacing and 30-inch corn rows, you end up with having some math that doesn't work out every once in a while. So if you do a 15-inch nozzle spacing, you could use every other nozzle and get that desired distance, so that way you can go in and make that kind of an application. Same way with, say, drop nozzle applications for like the sweet corn example I mentioned. Most all of your calibration tables are based on a 20-inch spacing. So if you have more or less nozzles per say given foot of spacing, you need to adjust your calculations in when you utilize those tables, and they will note that very clearly how they're calibrated. But 20 inches is by far our standard spacing. So nozzle body and screen suppliers. So there are all kinds of companies out there. Again, these are not endorsements, but merely starting points. So if you're lost, at least you have some places to start with. T-Jet, Hypro, and also Greenleaf are some brands that deal directly with agricultural sprayers. I'd pull just a sample example from this. Happens to be a T-Jet guide. So this is an example of the references. You can't read it, but down here in one spot, this is a whole table that gives all the gallons per acre at given speeds. It tells you what screen to use at different pressures, and gives you all kinds of really useful information that you would know. It also breaks down some of the other nozzle information, spray patterns, and things of those sorts. These companies have a lot of good resources to help you guide through their products. So whatever company you choose, do look at those resources, because they will give you a lot of really good guidance as you go through it. Nozzle bodies. So you can have nozzle bodies that are either with or without a check valve. So the one on the left that you see pictured is without, and the one on the right has a check valve on it. So these valves prevent nozzles from dripping whenever they're turned off. So obviously you have pressure build up in the hoses, or boom, when you turn it off, if you don't have a check valve, they'll want to just kind of drip and dribble. Depending on what your boom might be traveling over, maybe when you're turning or other things, and depending on what you're spraying, it is nice to have those. For one thing, it is good that it holds a solution in there, so as soon as you turn the boom back on, usually you instantly get flow. You don't get air pockets and voids in there from solution that's dribbled out. And especially if you're spraying herbicides and you turn over something else, you can often see the little dribble marks where it will maybe kill things, maybe when you're making turning and other things, if those nozzles don't stop dripping. Not essential, but is something to consider. Without a check valve, so on the example on the nozzle body to the left, you may want to use a ball check valve nozzle screen. So you can that would be the difference between those screens. So if you have a nozzle body with a check valve in it, such as the one on the right, you don't need to use a ball check screen inside that nozzle body. You can use a ball check screen in the ones that don't have the check built into them. Now you say, well, why don't I just buy the ball check screens? The nuance to that is, with over time, I personally have experienced this whenever we've had situations that were without the check valves built in. The ball check screens, remember, you have basically a little mini, like, kind of ball bearing ball on a spring. And if you get, say you're spraying dry or flowable products that are thick and tend to clump and clog up things, those will, and you don't get that sprayer cleaned out really well, those little balls that sometimes will get stuck. And then if they get stuck, you'll have one nozzle that's spitting and squirting and isn't getting the right flow, and it can really mess with your calibration. They do work, but it is something, you probably want to make sure you clean your screens, and certainly don't just, park the sprayer and leave it full of what would be kind of maybe a thick solution that could clump up. If given the option, this is just my opinion, and if I was starting from this, I would invest in the check valves built into the nozzle body. They do work really well, and they are less troublesome than the ball check screens. There are tons of types of nozzles out there. This is just one little spattering of things, and I'm going to show some other resources. Again, this just happens to be something from TJet. Greenleaf and Hypro also offer very, very similar options in these nozzle types, along with other companies. They all have different purposes. They have different droplet sizes, which can be good for different purposes, different levels of coverage and things of that sort. So I don't even know, we could do a whole session on just different nozzles. So we're just going to kind of hit the tip of the iceberg on this. Here's another more detailed screen. Again, for consistency on this, I just continued with the TJet, and I think there was another 2 or 3 pages like this of different nozzles. Some of these have some minor differences between them, but anyhow, this gives you a really good idea of just the amount of diversity that is out there. And then this also rates them for the different products that they would be useful for. So again, lots of different options out there when it comes to nozzles, all of which have pros and cons one way or another. One thing I wanted to highlight and show a little bit that I've utilized, and if we think of crop protection, especially some of our insecticides or fungicides that we're spraying over dense canopies, we will have we'll need to try to get really good coverage in this dual orifice nozzle, which you can see here. So this has basically makes two streams or bands of solution rather than just one straight down, and they throw out at an angle, so as you're driving, one's kind of angled forward and back, and these really help to get under dense leaf canopies and really do a good job of getting good coverage. So you might invest in this, especially for insecticide and fungicide sprays, if you don't have an air blast sprayer and are still needing to achieve good good coverage. Nozzle size, so you'll see these numbers like 110.02 and 80.04. Basically in this case, the first 2 or 3 digits is the width of the spray pattern. So as you would look at the nozzle from behind, the degrees of the spray, so being 110 gives a wider pattern than an 80. The last 2 digits would be the actual gallons per minute. So that shows you the output measured at 40 psi. That's a standard across most all companies. So, and that is in tenths of a gallon per minute. So that shows you that an O2 nozzle, such as the 110.02 I listed there, gives you 0.2 gallons per minute at 40 psi. An O4 would be 0.4 gallons per minute. They are all color coded. Most companies kind of utilize the same system, like an O2 would be yellow, blue is O3, red O4, etc. And this is, so those colors are very meaningful, and once you know that, that's a good go-to to know and understand things as far as what nozzle size is. So what are some general recommendations to boil this down? Your nozzles can have a huge impact on your spray effectiveness. And this is again just a brief snippet of what we could go into. For herbicides, your flat fan or maybe turbo T or air induction nozzles would work. The flat fan do provide better coverage for your contact herbicides, but you have some systemic products, say glyphosate for one, where larger droplets is fine. And larger droplets, so it's your air induction or your turbo T nozzles would have, gives you less drift potential. So that's why we're looking at these. And why we like nozzles that have coarser patterns is when we have these products, we can use larger particles and droplets. We greatly reduce our potential for drift. Protectant insecticides and fungicides, often these are contact products, and I would look to a flat fan, a dual, or one of the dual orifice options. There's a twin jet, there's another company that has a twin cap, there's a twin turbo nozzle, and these are ones like I referred to in that earlier slide that have 2 jets and do often give finer droplets, but also give better coverage with that dual angle spray. So to kind of, as we wrap up, add some details, I want to just give some sprayer examples. Some of these are ones that I actually have on my own small farm where I raise pumpkins. This is a sprayer that was dedicated for insecticide and fungicide sprays. This was an old ag sprayer from that I picked up from a local grower. It had a 300-gallon tank on it, and it was, and it actually had like a 40-foot boom. I switched it to having about an 18-foot boom that was off to one side, and then and mounted all new nozzle bodies and got a smaller tank that fit my needs. So there you can see it extended in that picture. So here I have 5-row blocks of pumpkins, and I can go down one side and back the other and thoroughly and effectively provide spray coverage to put on crop protection products to maintain insect and disease control. It works great. It's simple. I did not bother with, I could do the other boom if I wanted to, but for what it's worth, I'm perfectly happy, backtracking down each side and making those applications. Here is how I plumbed it. So this is a case where I did go off and plumb this on my own, and then I think that was a fairly wise decision in this, considering I have all of this under one control. I didn't have a need to have multiple sections of this boom. You can see there's a line that comes down down from the pump comes up. There's a pressure regulator. It goes out into a cross in the center that goes up to a gauge, and then down to there's a small valve for agitation, and then that big brass ball valve is what actually turns on the flow to the actual boom itself. So that is just a that's how I've managed that, and that's a very simple an effective way to do that where you don't need multiple sections. So this is a different sprayer setup. Again, this is an old sprayer. This is actually one that was on our farm that my grandpa had purchased. I took it, cleaned it up a little bit. It did need and cleaned up some rust and paint, but from there I outfitted it with some new components. In this case, this sprayer actually does have a wet boom. So if you look closely, you can see that the nozzles are directly on there. In this case, that is on a galvanized pipe. Now, I do not recommend that, and that's because my experience would tell you that rust, especially on older pipe, can be a major issue. There is always the exception to, well, if you have the parts and pieces, sometimes this is just sometimes you put up with some things that are less than the best. And this would be the case. I make do with it. I make special provisions to keep it clean, and I do clean the screens a little bit more, and it does work. I would not start from scratch on this, but I had the nozzle bodies already, and I made it work. In this case, just as an aside, this sprayer actually is parts of an even older sprayer. The booms actually came off of an older tractor mounted sprayer, but they are really nice, and if you kind of see it at the center where they're attached, there is a spring and kind of a breakaway system that they can flex back and forth should they encounter, the end of it should encounter something. So this would be something great for using for just general herbicide sprays. This has a boom that's 20 feet wide, which is definitely manageable for some modest to smaller acreages. This case, there is actually one of those multi-position control valves for the different sections of the boom. In this specific example, T-Jet makes this. They call it a T valve, a TEE valve. And this has, again, it has ports for a pressure gauge, it has ports for all three sections of the boom, and then it has a pressure regulator port where you can have then a bypass line going back. In this case, we have a roller pump as pictured here and in the lower corner, and that is that basically gives you, in this case, feeds feeds the pressure for this specific system. One other thing, and this actually I saw at a conference, and I don't have one of these, but it was just an intriguing, different idea and concept, is kind of a walk-behind sprayer. So this is a manufacturer produces this. How I see it, it's basically a small ATV tank mounted on kind of a single wheel, almost in the action kind of like a wheelbarrow type situation. They've made some small booms and plumbed it. Just the plumbing would almost be identical to what you would see on even a larger tractor sprayer. The difference here is they do have a battery, 12-volt battery mounted. You can't see it, and they have an electric pump. And then you can see in the center there on the top of the tank, they have their recirculation. They have a control valve, and also a throttling valve to manage pressure. So again, in this case, walking at an even pace, you can, with the proper protective gear, you can do a lot of applications with this. Note that they also have the pipes, the side of the tank allow you to raise and lower the booms up for depending on the canopy that you're trying to cover. Some other just general thoughts. So our target spray volumes, these do vary by product, and again, I'm not going to get into those details, but if you're just wanting some starting points, a lot of our herbicides, if we focus between 10 to 25 gallons per acre, that's a decent start. 10 would be something I would use for some 10 to 15 or 20 might be soil applied. And systemic products would be the lower end. The higher end could also be soil applied, but also it would be your contact products that need better coverage. Protectant fungicides and insecticides, especially on established crops. We often look in specialty crops for, and vegetables anyhow, for a larger volume. 25 is probably a low end. In some cases, 50 gallons. In some of our orchard crops where we have even larger canopy to cover, we may be even shooting for maybe even up to 100 gallons per acre. Other thoughts, having a speedometer for some form of calibration. This could be handheld, it could be on a phone app. With smartphones, there's all kinds of really good free apps that you can find, or low-cost apps that have speedometers that work off of often GPS. I look for one that would measure down to the 10th of the mile an hour, not just whole miles an hour, because for a lot of our smaller implements, that 10th can make a big difference where we're talking about speeds usually under 10 miles an hour, maybe under 5, so that way we can get fairly accurate. Or you may have, in some cases, a speedometer on equipment. I've seen bicycle speedometers mounted on four-wheelers and, that measure in tenths. Those are other options. Make sure you're calibrated, especially when you start off. So know the speed, the gear, and things you need to run in, and have some way to keep that constant speed if it's an ATV. And maybe do a trial run with just water over a small area where you know the volume, and see how things work out. There's lots of charts and tables by your manufacturers, so do look and search and research for those, and that will help you to determine the best means of the right nozzles, and then how to get them calibrated and help you hone in on that. The last thing I did want to just briefly talk about is backpack sprayers and other smaller sprayers are definitely out there. And some things you can utilize, because those are great resources that are definitely a lot better than just a hand pump up sprayer. The backpack sprayers give you the ability to pump on the go, so you can have a more consistent level of pressure. If you're spraying especially herbicides, you can get these small shields like you can see in the picture to the left, and also they do make, in this case there's a 2-nozzle version that is actually somewhat geared more for research, but they have shields on those, and those shields allow you to effectively apply products very close to maybe a sensitive plant, and especially great for weed control on small patches of berries, brambles, or even just around other vegetable rows, between rows of black plastic and things, where it gives you a great deal of control with minimizing any potential for drift. So that's just, again, another brief idea. Also on backpack sprayers, sometimes you'll see diaphragm versus piston pumps. And you can find resources on this. Either one will work if you're using more dry products, or maybe some fungicides or flowable products. On those, the diaphragm pump is more durable to those abrasive products than what the piston pump is on backpack sprayer scenarios. So hopefully, just in wrapping up, this is some good basic information to help guide you when you're building a sprayer, especially as far as how to plumb everything in, and where, as far as a go-to, as to how you can maybe even take old sprayers and make them into something new again. Those, no matter what it be, if it, a 3-point or pull type, or any components you can get, can be a really good basis to build on, and kind of really the sky's the limit as to how you can utilize these. Hopefully you can gain the differences in pumps, plumbing, screens, and nozzles, and just some basic ideas to help you put things together correctly, and then from there guide you further to help kind of look at where you can go to ask more questions and kind of be knowledgeable where you need to start. The last thing that I do want to just briefly mention is that we do have a state fruit and vegetable newsletter called the Illinois Fruit and Vegetable News that you're welcome to get email notifications for. If you do not, things like this webinar series are listed in it for events, and we try to have pertinent information. From time to time, we do even talk about sprayer applications and things in there that might be useful. So you can shoot me an email to be added to that. And the link is also in the chat box if you want to see that. And if not, Thank you for your attention in this. There's a great deal of information out there, and so hopefully this answers some basic questions. If you have other questions specifically or things I haven't addressed, I am happy to do that now.
Well, thank you so much, Nathan. There's a lot of information there, and we have this recorded for your reference if you have to get off the call and refer back to this. We have a couple questions. Well, one earlier that you sort of addressed a little bit in the text box, but maybe we'll revisit it for everyone else. The question was relating to smaller operations that use smaller equipment, 30-gallon tow behind lawn tractor, and they're struggling with adding an agitator to the sprayer. Can you offer suggestions or guidance? And you sort of referenced, replumbing sort of bypass valves back into the tank for agitation. Is that a common practice, as most smaller sprayers typically don't come with agitators?
Yeah, no. So for small ATV sprayers, I would look to you can get those especially the jets that you saw, the one in that second image of the plumbing that has this like a little inductor jet that has a stream that goes through and it kind of siphons material through to circulate. You can certainly through your local farm supply or certainly sprayer supply companies, they make agitator tips, and if you noticed on the agitation slide, that gave some good line drawings of some different devices that you can that they make for agitation. Basically, I would in probably a poly tank, hopefully find a spot on the bottom of the tank that you could add another bung or just a threaded port on that tank to add in either on the side or the bottom, a place that you could put in an agitator. In some cases, I have used if there's a recirculation on the tank, which the 12-volt systems may not have, but if there's any agitation, any recirculation, I sometimes have used that as agitation. The only nuance to that is you don't want to restrict your bypass too much. So if your agitator has a very small opening, you don't want to drop that too much.
Yeah, I think they're referencing that there in the person who asked that question. Mm-hmm. Simply adding an agitator drops pressure too much for it. Kind of got cut off
spraying. So this is where although you want to run agitation while you're spraying, you may, what you'd actually probably in this case to really have agitation is you probably need a larger pump. Now that isn't to say that you couldn't, maybe not the best, but I know sometimes, when someone says you need to spend more money, it's not your first, you're like, oh, that wasn't what I wanted to hear. How could you maybe kind of get around that? At least to give some agitation, you could go ahead and plumb the agitator in and put in a valve. This isn't ideal, but it would give you some agitation that you could open it and have it agitating when you're not using that handheld wand, at least to keep some things mixing. And then if you're needing to spray, you can turn that off, say when you're moving tree to tree if it's a tree crop, and then actually make the sprays with that agitator off, because that's the kind of the take home of sorts on that. But so in that case, you're not trying to use the pressure at the same times. You're still getting some agitation, because that's a solution will stay in suspension, for some amount of time. And especially that agitation can be good when you're trying to get it initially mixed. If it's mixed well to start with, it'll stay in solution a lot better. This being said, logistical issues are yes. The answer is yes. There are lots of logistical issues, and that's part of what I tried to break. Making this presentation, I started on the simple end, because you have to understand how things really need to flow through the system to be able to kind of address those logistical issues. So JP, that may even be something that I could attempt to help you with one-on-one. But in some cases, getting a bigger pump that could handle feeding both your agitation and your wand might realistically be the route to get you continuous agitation, because a pump can only, it will only deliver that max volume and pressure that it's rated for, and it can't do beyond that. So
Nathan, I have a quick question in
mhm.
reference to backpack mist blowers. We would
Uh-huh.
often see these at research farms for
Yep.
trials in orchards, but I've seen some growers on some Instagram accounts utilizing these for other types of products as well. I mean, obviously, there's limitations to the smaller ones, backpack ones, because they're only 3 gallons at a time. But would it be true in general that these mist blowers, given the correct environmental conditions, that would be a better way to apply product at a smaller scale with these mist blowers?
Yeah, so for the sake of time, which I obviously still went a little over, I didn't even get into the whole air assisted mist blower side of things. But any air, whether it be an air blast sprayer or just that backpack mist blower, anytime you add air to that, you're using that to help force that solution and spray solution into a crop canopy. And so because of that, you are going to get better coverage. And yes, the one limitation is that it's hard to find a good in between. So where's the in between the 3 gallon backpack and the some of the smaller mist blowers? Uh, there's some struggles to find maybe a modest air blast type sprayer. But yes, they are excellent. They are excellent for good coverage, especially in orchard crops and things like that. And in some cases also for other vegetable crops, as far as trying to get good coverage over for especially your protective products.
Okay, excellent. Well, I want to thank Nathan so much for the fabulous presentation and sharing his expertise, and I want to thank everyone for joining the webinar. Hope you received some good information. Hopefully you can put this together for your sort of pest control program this upcoming winter. And look for an email for the archived version of this webinar if you had to get off early. And look for a very short evaluation of the webinar as well. And we really appreciate your feedback on these webinars as it will shape next year's series. So with that, I want to wish you the rest of the day a great day, and we'll see you next week for our final winter webinar of 2018. Thank you very much.